basically capture the way the view visibility is set up per view and create a template and apply the view templates and transfer them from project to project. So view templates, there's a bunch of them that come with Revit built in, and we can change those view templates as we please and then alter them and save them and transfer them from project to project. Very powerful. Another great shortcut, view templates, working with their visibility graphics. So everything up to that point is all kind of standard Revit stuff. And then we get into the really juicy stuff, which is the structural thing. So we have our structural physical model where we go in and we model our structural stuff. Columns, beams, joists, purlins and trusses and load-bearing walls and foundations and slabs and footings. We model that. As we model that, the structural and analytical model, the fun stuff, this is the structural schematic or stick frame of the physical model that is being created automatically. And then you can tweak it and go beyond the physical model. So structural physical model, structural analytical model is really the meat and potatoes of Revit structure, where we can model and then look at it, and it's all color-coded line work. So beams are one color and columns are another color, load-bearing walls are another color, and then we can take those and look at them in different visibility states, just like as if you were looking at it as a third-party structural analysis program. And then we can have a look, and we will look at that as soon as I'm done all of this tech stuff here. We'll have a look at the model. Okay, we have boundary conditions, fixed and pinned and roller, and user-defined conditions. We have loads. Okay, loads is once we model it and we have a look at our stick frame analytical model, then we can go in and we can create case loads for live loads and dead loads and wind loads and snow loads and seismic and all kinds of great stuff. We can use combination loads of everything above. So then we can take these loads and graphically apply them to our model. And it shows us a little diagram of the different loads, be it a linear or an area load or a distributed load, all the fun engineering stuff. Okay, and we take those loads that we have defined as live and dead loads. We can factor those loads, of course, and then we can apply them to our model. Fantastic. Then we go to our analytical support and our third-party analytical integration. So we then take our analytical model in Revit and we say, okay, show me the integrity and the connection connectivity of all my structural members, and Revit will point out to you whether there's a miss between the connections. It'll say, oh, there's a missing footing here, or there's, you know, a beam that's being held up by a sky hook, or there's a, you know, a column that's got a problem. So it'll point out the problem areas with our analytical support check, and then it'll zoom us to that part of the model, and then we can just fix it and change some offsets and do some neat stuff with that. So then after we do all that, we then prepare it and we export our analytical model or our structural model to a third-party analytical software. So third-party analytical integration, yes, you can export the structural model to one of 3 structural analysis programs, and then that will analyze it outside of Revit, and then you import it back into Revit, and what it will do is it'll make the changes in the, if you make changes in the analytical software, the third-party software, you bring it back into Revit, it actually shows you where the changes have taken place and where the problem areas are. And then the extent of that lesson I have a to be announced, because we'll see how far we get with getting that third-party analysis software installed and running. So that's all the good Revit structural stuff. And then of course we can import and export views or sheets to a DWG or DGN. So we can actually take our Revit 3D model and export it to architectural desktop, and it actually, I think it's easier to model it, a structural model in Revit, and then export it to architectural desktop in full 3D with all the columns and beams and joists. It turns out better than if you actually try to model it in ADT. So if someone wants a 2D flat file of one of your floor plans or framing plans or your shear walls or whatever you want, you can export either the whole sheet or just one view of your Revit model to a DWG or DGN, and you can likewise import them. If someone gives you a 2D flat file of an architectural drawing, you can use that DWG file or DGN, bring it into Revit, and then very quickly trace over top, or even snap to the imported objects, and very quickly get your Revit structural model up and running from that imported file. We're going to talk about families. Families are very much like blocks in AutoCAD, but much more sophisticated, of course, and we'll use them, and we'll create some custom families, and we'll do some general work and management and copy and paste and moving from project to project and all kinds of neat family stuff, family types. We'll talk about stairs and learn about modeling stairs in 3D and creating multi-level stairs, and much more as the lessons start to develop. So combined with perhaps some of your suggestions and or these topics I've just covered, we'll be filling in the cracks with all kinds of other little stuff. Obviously I can't verbally and written cover everything we'll do, but this is really a good chunk of what we'll be doing. And I just have a note at the bottom here for roofs and phasing and work sets and custom families. I will refer you to our cadclips.com webpage, where we have some extensive lessons already created on those particular topics, and I don't really want to repeat them because they're still perfectly valid and they were done quite well and have had good feedback. So we will be doing some roofs and some custom families, but for the most part, if you want more detail on roofs specifically, and phasing and work sets and custom families, have a look at our cadclips.com on the left hand side where the Revit is, and we have more lessons on there. So now I've just zoomed in here, and all this is a bunch of text in my Revit model. I'll just have a quick look at my 3D model here, and I've just got a little bit of a teaser here, and I've just got a 3D model. I'm just demonstrating how you can take a slope beam and tie a beam system, okay, this is a beam system, all these guys, and tie it to this beam, and then if you slope this beam, the whole beam system will then slope with it. And you can see that I need to fix my offsets on there, but just as an example, okay, I can click on this beam system, and I can go into the properties of it, and I can say, okay, it's not a W8, it's an actual open web steel joist, and it'll change all those in that beam system to be open web steel joist, and it'll update the model for me. And then it'll turn those into joists, which is quite nice, and I can see there's a problem with this guy inside of here. Need to fix the offset of that guy. I'm going to go back into here and say, oh, that's, I don't know why that one I've been playing a little bit, should be only a 4-inch offset, so I can fix that one up there. Okay, I can also take this particular beam and go in and have a look at this and say, you know, there's a 4-foot offset. Well, if I bring this down to maybe, you know, bring it down another 2 feet and say it's only 8-foot offset from level 2, that will slope, and then we'll also see my beam system, and all my joists will slope on top of that, will fix themselves up. And you can see that my generation, I think my recording software is also slowing me down here a little bit. And we can see there my beam got dropped down, not necessarily a ideal scenario, but fair enough. My joists have, because they're tied, that beam system is tied to this spandrel beam over here on the outside. All my joists are going to slope with it. So there's just an example, an extreme example, I should say, of how that works. And then I'd have to tidy up this corner in here, okay? So then I've got some foundation walls, I've got some footings, a few columns, another beam system again over here, and you can see you can click on that beam system anytime, structural beam system. I can go in there and say, okay, you know, W8s instead, and it'll switch that up. So you can very quickly go in and do this. This is just a tip of the iceberg of the power of what you can do with Revit. And then of course I can change my visibility to say wireframe, and now I can kind of transparently see, you can see the blue column, that's the analytical model. The tan, the light line is a beam, and then the green lines are load-bearing walls, and you know, so everything's color coded. And I can switch over here and say course detail, and now all I'm seeing is the actual analytical model in the background, which is quite nice. And the engineers like this, it starts to resemble the actual third-party structural analysis program, so we can flip between, and it depends if I'm looking at level 1 or I can zoom in, I can look at level 2. Okay, as I look at level 2, I can switch between different medium detail. It's going to show me more detail. I can show fine detail, might show me more, it might not, depending on what I've got modeled. Okay, go back to being coarse detail. I can go to medium detail and shaded, or I can go wireframe. Okay, or I can go hidden line, or I can go shaded, and then so we can play with our different visibility, and this just happens to be level 2. If I go to level 2 analytical, level 2 analytical looks like this, and inside of here, once again, we can look at different detail levels and different shaded views and stuff, and we'll have a look at that. Now, analytical specifically is designed not to show the physical model. It's there only to show the analytical model, which we can see there's a column which is blue, and there's our beams. Okay, back to level 2. Well, level 2 is an analytical view. It's a regular physical view, and it's designed to be that way. We can see it's got all our gray tags and stuff on there. So this is, again, just a little bit of a tip of the iceberg of what we can do with our Revit structure.